All right, we are now recording as well. So welcome to VIWeek 2020, the first time and hopefully more to come because this has been a great experience. I haven't gotten to all the sessions I wanted due to work constraints, but I'm glad I could at least be here with this. Um, so serial communications has been a big problem that I've been running into, mostly on the forums. We get a lot of new people who are playing with an Arduino or a Raspberry Pi and they don't know what to do with it. And they're trying to talk with LabVIEW and they wonder why they're not getting the data properly. So, so that's the basis of this presentation. So about me, I'm Tim Robinson. I'm a test engineer in the Cincinnati area. I've been using LabVIEW since 2005. Look me up on the forums. I'm Crossrules. Everyone seems to know me. LinkedIn, I've managed to get the Crossrules LinkedIn address as well. So I'm a LabVIEW champion, LabVIEW architect, I'm an embedded developer, and for later use, I do have this presentation and the examples on GitHub with that link there. All right. So when people first start with the serial communications, they look up example helper or example finder, and they find simple serial example. And this is where things go horribly wrong. My first major complaint, and the one that most people who know anything about me, is going to be right here, the bytes at port. Please, for the life of God. Oops. Oh, hold on. I stopped the annotations. I actually made a macro in the forums, specifically bytes at port. And I emphasize this, do not use the bytes at port with 10 million exclamation points because it's still not enough emphasis because it's wrong 99% of the time. We run into this constantly. It's all because of this example. So basically, I mean, the example is not horrible, but it's just a bad structure from the beginning. So yes, they start by initializing the port. Good. We're saying a command that's a standard command for most box instruments. So that's probably the other problem that we have with most people. They send this identification command that's a Skippy compliant command, but people are not using Skippy when they deal with their microcontrollers and Arduinos. So therefore, bad command structure from the beginning. And then we wait so long just for the command to get processed and then see how much data is there and read it. The problem is this creates very weird race conditions because I have literally had it so I wait so long, I read it, and then I get only like a third or a half of the command. And people are like, what happened? Where's the rest of my data? Again, the bytes at port is what's messing you up. The wait also is not actually needed either, which thanks to late Dennis Knudsen for correcting me on that at one point. So we have better ways of getting there. So again, I create a macro because I have to deal with this issue enough that I just have it typed for me. Then the next example, the continuous serial write and read. This one's not as bad. I mean, at least we're conditionally reading and writing. We're not using the bytes at port, so that's an improvement. My issues with this one is the X on X off flow control. I've only seen one instrument in my entire career that actually used that. I'd say it's probably better not to have it in there in this example if we're trying to keep things simple. The other issue is what command are we sending? And with the read, we're just grabbing lots and lots of data, so people can easily run out of memory with that as well. So these are the 7 points that people start out at, and they're okay, but there's a lot to be desired. And my biggest issue is you need to know what your protocol is. See, that's the problem. Biggest problem with these examples, they have no idea what the protocol is. And I just made some very generic setup. But in order to do anything real, you need to know your protocol. And I've basically come down to you have two different parameters. You have when data is being sent out and what the format is. So when is its response is it comes back when you ask for it, something. Stream, something's constantly coming out, and intermittent, it comes out and who knows when. And we have to handle those in different ways. And then data format, we have an ASCII, and then I call it binary. I've heard people call it hex. I've also called it raw, just as another delimiter. Um, so again, the when response is data is only sent out from the instrument when you request it. Most bench instruments, like your DMMs, oscilloscopes, power supplies, etc., they will do this. I've had a few that will stream based on certain commands that you've had, but most instruments are going to be a command response. So it's a very serial process. You send a command, you wait for the response to come back. The stream data is constantly being sent out, usually at a set rate. I've had some that waver a little bit on that, but I've had some that send out every 100 milliseconds data. I've had one send out every 16 milliseconds, which actually is exactly the length of the command. That one was annoying to do. But most devices that I've seen being developed with the Arduinos especially, they just grab the data from the ADC or whatever, and they just spit out the data. Then the intermittent. This one's probably the most annoying to handle because you don't know when stuff is coming out. It could happen. Let's see, there's one that on the forums where a device only sent out when a user pushed a button actually on the device. I've dealt with one that only sent out when a value actually changed. But then I also throw in with this one if they're slow, as in they've sent out data every 1 second or 2 seconds. So again, these are instruments that usually only care about when stuff changes. They send some out. The way to handle this one is similar to the stream, but you need to make sure that you're handling when there's no data available. And we'll get more into that when we get into the examples. But the important thing with the intermittent is it can actually be used for both the response and the stream if you set it up correctly. So any questions on these at the moment? Someone comment on the X on, X off, only needed it once in 20 years. Yeah, I'm about the same boat. I've never personally dealt with an instrument with it. So, all right, in the right window. The other important thing is data format. So this is where I probably have the most problems getting stuff around people. So ASCII, if you're getting the command and you can read it in a text editor, it's ASCII. So where I've ran into some problems is people say I'm getting hex data. Well, the hex data is actually in a format that can be read in a text file. So therefore, I call that one ASCII hex because it's literal characters that are 0 through 9 and A through F. So that's different than our raw binary and hex that we'll get into in a minute. Skippy devices, which is most of your box instruments. Skippy is based on an ASCII protocol. It's very simple, well, mostly simple to use. And most importantly, the ASCII formats almost always, if they're worth their grain of salt, they end with a carriage return or a line feed. So this is what we call a termination character. So we need to use and abuse that aspect in order to properly read our data. And if you're using Arduino, I'm not an Arduino expert, but I've figured out enough by helping people on the forums. There's a serial.println command. And if you use that, it actually adds the carriage return and line feed to the end of your stream. And we can, again, abuse that. Arduino actually uses hardware handshake signals. Okay, I did not know that one. Again, I'm not. Yes, termination character madness. Or add /r/n. /r is your carriage return and /n is your line feed. The help I found on the Arduino for this command is it sends both. All right. More on ASCII. So here's the most important thing you should ever learn if you're watching this. This is the only screen you remember, I've done my job. The visa read. It stops reading when any of these three conditions are met. When the number of bytes you told it to read is read. When the termination character is read, if you enabled it. Or neither of those happens, but you time out. If you're using defaults, that's 10 seconds. I've set it to 2 seconds before. Um, just depends what on your device and what you expect. So if you're dealing with ASCII format, you enable termination character. By default, it's on if you use the Visa configure serial port, and it defaults to the line feed. It's probably about 75% of your devices will end with the line feed. I've had quite a few that will end in a carriage return, and some end in some other weird characters. But for the most part, just your defaults from the Visa configure serial port will work. And then when you actually perform a read, you read more than you expect to get back end message. Depending on the device, I will use 50. I have some that I need to set to like 100. For a more generic setup, I will set to the 4096. It's all on whatever you need, as long as it's more than the message is expected. What other? Okay, we got a bunch of questions I see. How do you handle protocols without termination character, but length in the message is... I think that's if you're getting into a binary format. That's usually what you have with that. If it's an ASCII, then I have not seen that. But I would treat it more as what I will talk about with the binary setups. And some instruments send both, yes. Most instruments actually send both the command line and or the carriage return and line feed. In that case, you set your termination character to be the line feed, and it'll take care of it. It's moving to okay. Yes, check which one is expected of your device. Rule number one: know the protocol of your device. Read the manual. It'll help you a long, long ways. Yeah, double send. Is there a way around bytes at port? I'm not understanding the question there. Let's see. Chris, the instruments I'm working with send a header that contains the length of the ASCII string. I have dealt with those as well. Again, I'd probably treat it more as like I will the binary hex, where I will read so many bytes that I expect for that length, and then read that length. We'll get into that in a minute. I've only a protocol that can use different start of message characters, different termination characters, and may or may not send a checksum after the line feeds, or may or not be one. Okay, that's getting into a whole mess of. All right, let me read this one fully from Aaron. How about a protocol that can use different start of message characters, different termination characters, and may or may not send a checksum after the line feed, which may or may not be one of the termination characters? I'd say if you're using an instrument like that, you should throw it away because they did not think through their protocol at all. It can get very messy, but I think we can get there if it's structured enough, and we can get around our structure correctly. I think it's when we get into examples, we can probably examine that a little more. So I usually seen code to looping with read with bytes at port. Always felt like a bad idea. Yes, it is a bad idea. My only exception with that one is if you're actually just making a simple terminal read. If all you're doing is reading data and showing in a string, I use it for that. Have you used Visa events? I have not. I haven't found a good use for them really, because eventually you're still getting to the timeout situation with them. I haven't examined them very closely, but it's still a very serial set up, so I don't see much use in them. At some point, instrument has to have a protocol interface design that actually be interfaced with a reasonable way, or it's just garbage. Amen, Josh. Um, then, okay, Dan Shangraw has used Visa events with great success. I will have to examine those again when I have a chance. They're great for intermittent comps. Okay, I will have to look at that. Usually my loops need to go a little faster, or I'm constantly doing something, so I don't like using something that's going to sit there for a while. Wait on termination character event and found them very helpful. I will have to re-examine that. We always investigate instruments before we buy, absolutely. With few exceptions, if it isn't Skippy compliant, we won't buy it. Again, yeah, again, Skippies are very common with. It's scrolling too much on me. Let's see. They are always instruments. People making device to test aren't great at making API, but you still need to talk to them. Yes, that is very true, Norm. I've ran to a few of those. Um, Again, there was one that sent data as quickly as the message could possibly be sent out. And when I was tried to connect, uh, actually start and stop characters would, or the data would actually look like start and stop characters like as soon as I started connecting to the port. And so I had to do some reconnecting and finagling in order to actually properly line up the messages. That one was a pain. I will check for the error. The number of bytes transferred is equal to the request to know if there's more data to read. That is not always true. Sometimes you read exactly what you should. Again, if you know the protocol, it's better if you know the protocol. Steve Watts, the more specialist the hardware, the more awful the comms is. Yes, I fully agree. I have ran into that plenty. All right, I'll move on. Oh yeah, I was going to do code at this point. All right, so we're dealing with an ASCII. So basically, I made a very simple, we'll call it an instrument. I have an emulators here. So based on the three types, and basically all they do is they generate a random number, and they can accept the command for what the max and min of that random number is. So I'll start with my terminal. So I'm going to use 9 for him. These guys I'm on what, 10. And literally what I have is I have two USB serial ports, and they have a null modem cable in. So therefore I can just talk back and forth with them. And so I'm doing the command response right now, so start him up. So what I'm doing here is I can do a ping just to make sure he's there, and he's in the back of Pollen, or I can just do a read. And so he's just getting random data. Apparently this one's already set to 10, plus or minus 10. So the way we handle that is with this. So I reduced my timeout since I expect a response fairly quickly. So that's why I reduced it down to 1 second. If I take longer than that, then I have other issues. So the next VI, I have a little VI that sends the command. So this gets into some fights that I've had where I used to be on the other side of this argument as well, but there's if you go back to the, I think it's the continuous stream example, there's a property where NIVisa, sorry, there's weather alerts, NIVisa can actually append the termination character for you. And so you don't have to include it yourself. I've gotten away from that for two reasons. One is I'm dealing with instruments that have more than one interface, meaning I could be over serial, I could be over Ethernet, I could be over USB, but that property only works for the serial. So for that, that's my main reason for not using that property. The other one is a lot of instruments actually do want both the character return and line feed, and that property only handles the one character. So my suggestion is make a VI like this one that specifically for saying the command. So it appends your termination characters, does what other additional formatting might possibly be needed. Um, so it's nice and simple. We just call from everywhere. So I literally have my command string that's coming from this. Then I'm reading the response. So I set this one to read 100 bytes. Obviously, we are not getting 100 bytes. We are getting only the data that's coming out, and it ends with the termination character that we've already set up. So therefore, I don't need to wait. Because the visa read is going to handle the waiting, it's going to handle the reading up until the termination character, or it's going to get timed out. Nice and simple. Yeah. So then I use the panel close event all the time for closing out my applications. That way, just hit the red X to stop. Um, any questions on this? Okay. So that's that's the command response. Streaming. There's where life gets more fun. So since we constantly expect data to come in, we constantly should read. So literally, I expect it to come fairly quickly. I left the default to be 10 seconds here. So I'm just telling the visa read 100 up to 100 bytes. Again, it should find the termination character long before that. Stop you. Stream. Run. Okay. Oops. Helps if I actually set the COM port. So I'm literally just getting data every, I think it's 100 milliseconds, I think is what I have it set for. So he's just constantly reading and sending data out to the chart. As far as actually sending commands, I have a send command button here, so I can actually send whatever I want. So I can actually do a max 10, I think is what my command was. Send that, and then you see my maximum value will be, for the random number, will be plus 10. And I made one for the min as well, so now I'm doing values from plus or minus 10. So again, I'm just using the simple button to write the command out. So any questions on the streaming?
There's one about why some USB to serials won't work with LabVIEW with a few models. I don't know if you know the answer to that off the top of your head.
I know there's been some counterfeit parts flown around in the world. I know FTDI is typically pretty good, but there's some counterfeits of
That's
those.
the one we go with.
Yeah. Personally, I like to get industrial ones from StarTech, which I think use a TI part in them. I've yet to run into an issue, except for one. I actually ran into an issue when I got upgraded at Windows 10. So that might have to be looked at again. It could be a driver issue, or just might not be compatible with Windows 10. I have to look at that one again. But FTDIs I've had good luck with. The ones I'm currently working with are actually Prolifics. It's a TrendNet adapter that I've used for a good 5-6 years consistently and never had an issue with Windows XP 7 or Windows 10. But a fairly good consensus is that FTDI is the way to go.
There's a quick question about why you're using a case structure for the send command versus an event structure.
Mostly because I didn't want to wait. The event structures imply that you need to wait for something to happen. And in this case, I didn't want to wait because I need to constantly read. And along those lines, I notice I also don't have a wait because I'm just reading data as quickly as the data is actually coming in. So I actually don't need a wait in the loop as well. Parallel event loop for sending that. Yes, we'll get into that in a minute. Yeah, we'll get into that. These first ones are supposed to be very simple examples that could be a replacement for NIs. we'll get into in a little bit. We'll get into what I actually do because these are way too simple for what I do. All right, so that was a streaming. All right. So our intermittent, it sends data whenever it feels like it. So in this case, I have a nice send button on the intermittent. So it's whenever I decide to actually send something out, we'll get new values out. I probably should have had a chart for this one, but whatever. So you'll notice I have the dreaded bytes at port in this. But with emphasis how I'm actually using it. I'm using the bytes at port to see if there's actually any data in there. So if there's any data in the port, meaning your bytes is more than 0, that's when we actually perform a read. I came up with this setup when I actually had to deal with a device that it was actually an Angular encoder, and it only sent out data when the angle actually changed. And since I was trying to constantly at the same time read a streaming port through the same setup, I couldn't wait for new data to come in, or else I'd get a timeout. And that's actually another weird thing I had. I actually got a timeout and therefore only half the message on the next read. So that's another thing to be aware of. I've actually started a read and then only got part of my data because it timed out. So again, the byte support is only used to see if there's data. So that's why I have a nice case structure here. If there's data there, then we're going to read it. Then I'm doing some things to clear it out, and I'm doing a response just for fun, apparently. Trying to remember the full details of what I did here. Did I get this? I have to re-examine what I did with my code. So if I didn't get data, usually I throw in a little wait. 50 milliseconds is fairly typical. Sometimes I'll make it 0, or sometimes 100, depending on what instrument I'm dealing with or how I'm dealing with it. But 50 is pretty much my go-to. So again, emphasize on byte support is not used to tell the VIWeek how many bytes to read. It's only used to see if there's any data. And then I'm still using the termination character setup. Any questions on the intermittent? All right. So race conditions with byte support you talked about are related to there being more than it returns, more data than it returns. The race condition is you might not get all of your data. So yes, there'll be more data than you actually read. And in many times you only get parts of your message, which is when it's bad. So yes, I have actually I've seen this many times. You do a byte support and you read it, and then you read, but when you check for the byte support, it only will say 5 bytes when your whole message is 10. So you only try to read the 5. Where if you tell it to read, if you just try to read 100, then it would get the full 10 and stop with the termination character. All right. I know some of you are asking, but Tim, what do you do in the real world? In the real world, I do actors. I am not a fan of actor framework, but I use a lot of the concepts of an actor. Trying to remember how I set this guy up again. All right. Anyway. So again, set him on 9. I shouldn't have closed these guys. So I have a parallel loop. We're calling it an actor, and basically I use a queue to send commands to it to do certain things. So what I've done here is I have a queue with a 10 millisecond timeout. So if we didn't get data, that's when I try to do a read, or there we go. If I timed out, this is where I try to perform a read. And I'm using the same setup as the intermittent. So that way, if there's data there, I read it. If there's not data there, then I just move on in this case. In this case, I'm using the queue as my timer for the wait. So I don't actually need a wait in there. So again, that's my intermittent. And part of what I do with my commands when I send out is I embed a queue inside. And so that way, when I get data, I can have my actor just send the data back out to whoever asked for it. In my real setups, I actually have it so I have weird lookups and whatnot because I'm dealing with a lot of terminals, uh, Linux terminals to be more exact. So therefore, I am looking for specific strings. So I actually have search for certain strings, and if you match that string, then you send out through the queue. It gets very complicated and tricky if you're not careful. Um, so where we want to go? So if we get a command, what command are we doing? We can actually just get data. That's where we actually say, here's the data, here's where you send the queue, or here's the queue for where you send the data. I'll get there a second. Or I can actually tell my actor to stop or send a command. So, and the heart of that isn't actually, I have an action engine here that specifically that stores my queue. I can, when I do a get reference, I'm actually creating the queue for sending to the actor. Other options is you can, let's get to it, or send or close. So those are my options for this guy. It's fairly simple. If you're getting the reference and there currently is no reference, you create a reference, create the queue, and we output that. Sending, you just do an in queue. If we're closing, then we destroy the queue. The important thing here, though, is that this action engine is protected inside my library. Only my actor can access that action engine directly, I should say. So what I've done is I have messages here to encapsulate my commands. So therefore, if I'm trying to request data, here's where I create the queue where I want my response data to come back, and I write into the command structure, and then use the action engine to send it. And then I got similar setups for telling the actor to stop and then to actually write a command out. So if I'm doing an intermittent, let's go to. So let's look at this guy. So what I've done is if I request data, I just say how many responses do you want. So here I'm saying the command to request the data. Then I just dequeue that many lines out. And then if I time out or I use up the number, I'm done. So request 10, it should take about 10 seconds, I believe. Oh no, I have to actually send the data. And I forgot what my commands were. That's stupid of me. Yeah, let's go to the streaming. Now request it, come on. There we are, now we got data. Yeah. So here's what we'll do in real life. So I use the send button to actually send the commands out to my actor. So then my actor then sends the data out to through the serial port. And this will work for any of the setups. If depending on your instrument, it will work with any the intermittent, the command response, or the streaming. I see a bunch of questions. I don't know where it all is going though. I
There was
see your.
just some discussion around bytes at port, and then the
Yep.
last one is what if you don't know the instrument response length?
If there are more than 100 bytes, that is when I will go. Well, if you go in my generic setup, I actually use the 4096. If you have a command that's going more than the 4,000 bytes, then you probably have other things to worry about. Um, so I would just go the mother load and just make a very, very large number, is what I've done. Risk to blow. How do I discard old data? Well, you could. Usually I'm getting data quick enough that I don't have to worry about that. As long as you're getting full messages, you're getting the data off quick enough. There is a flush buffer. I am not keen on that because you're literally throwing a bunch of data away, and you could possibly be desyncing, unsyncing. Sorry, you could be unsyncing your lineups to the actual command. So I'm not a fan of using that. And yes, I've done my own buffer management. That was not too fun. All right, all right. Any more questions on ASCII before we move on? I've gone a little longer than I thought I would. So, longest I would ever set a timeout for a read, 10 seconds is what I've been using for a default. As a default for most things. Um, it depends on the instrument, but I will often go to the 1 or 2 seconds, depending on the instrument. But 10 seems to be a good number to start at. Any word on good, simple ASCII protocol to use when free to decide? The simplest is if you're just streaming the values. That's by far the simplest. Otherwise, just make it very simple. If you really want to go full board, emulate Skippy. Skippy is actually a very good format. All right. Raw, binary, and hex. I default to calling it binary, but I've heard many people call it hex as well. Um, the biggest thing here is you need a hex editor or viewer in order to understand it. I'm personally a big fan of Ultra Edit. It has a hex viewer on it. Um, and I've gone through gigabytes long files parsing data using that. Not exactly fun for most people. Um, so with these, the protocol is essential. It is even more essential than if you're doing with the ASCIIs. ASCIIs are fairly easy to get around. These you need to have a good frame set up in order to properly do it. Um, so a typical frame that I've seen, you have a start byte, 02, which in ASCII is a start of text. That's what I've most commonly seen. Um, I, I want to say I've seen a null character used as well, or an FF. Those are the other ones I've seen. After that, you have a message ID, usually a byte or two, that says, here's the data I'm sending you, or here's the type of data I'm sending you. It's sort of a metadata. Um, then you may or may not have a data size associated with that. Oftentimes you can get the data length from the message ID, but there's also a lot of protocols that do not have the message ID. They just have the data size and expect you to figure out what's what. Um, and then you have your data, and then end with a checksum or a CRC, just some way to validate that you got the data, that got your proper data. Um, Typically, I've seen most instruments use a simple checksum, which is you just add all your bytes together. CRCs are a little more complicated, and you gotta be very careful of the standard you're using. And there's many variations of the standards, so be careful with the CRCs when you have to deal with them. All right. So any quick questions on those first? NDS variations, yeah, that's another story. I'm staying away from that mess. Okay. Okay, so protocol I'm using in my code here, I have a start byte, then I have a message ID. So I have 0, 1 hex is for the value, 2 is for the max, and 3 is set the min. Followed by the data. In this case, it's all double, so it's nice and simple. But I know the length based on what my message is. And then I'm doing a checksum at the end. In this case, it's just a sum of the message ID and the data bits. So where'd my code go? There it is. So we'll have similar setups. Yeah, find my.
There's a quick question here, Tim. Do you have a preferred hex editor viewer?
I'm a big fan of Ultra Edit. It is paid. It is a paid one. I think Notepad++ also has a hex viewer as well. I have not dealt with it though. There's another one I used. I don't remember what it was. It was a long time ago. All right. String. All right. Get you. All right. So same ideas here. Yes, I'm getting the number of bytes as expected because of the protocol I'm using. So basically, I have my instrument here. My max and mins are 0 and 1 currently, so I can set my max and set my mins. Nice drop downs. I made a better interface for this one because I dealt with it more recently. So here's where the fun begins. First thing, turn off the termination character. You can have your termination character be part of your data, which will cause all kinds of fun syncing up and you miss data. We'll just say that. So then all I do is I continuously read for that start character, or sync by is another term I've heard used. So I'm not doing any waiting inside there. I'm just constantly saying, read a byte. Are you my start character? If you are, that's when we go inside, say, what's my message ID? Then once I have my message ID, then I can start interpreting the data. So in this case, yeah, data point is a 1. So I'm reading the data. I'm interpreting it as a U8. That's going to my case structure. So then I'm reading the 8 bytes for the double plus the 1 byte for the checksum. And then I have a VI that just does the checksum. It just takes all the message ID and your actual data and make sure the checksum's correct. And then if that passes, then I just output data through my chart. So that's where the meat is with this one. You have to hit it basically one section of your protocol at a time. And that's also where it gets the most fun, especially. I know it looks weird because you get the pyramid structure going with your case structures. I have done this with a state machine as well. I find it harder to read as a state machine. So in this case, I actually find it easier to keep with the case structures going in. Will cause lots of visa overhead. Actually, I have not had an issue with that. Where I've done the alternative, way back in my times before I actually learned how to do this properly, I actually did the bytes up port and read everything and then parse the streams that come through. My problem with that one, the problems I had with that one is when data came out quickly, I very quickly slowed down due to memory allocations of the stream. So I say, how can I get around that? So that's when I came up with this setup. Thinking back at that project, and was like, man, I could have done a lot better. I have not had an issue with running into the buffer. As long as you're constantly reading it, it's fine. If you get the bad data or CRC, I just ignore it. And then I come back, loop around to looking for the start byte. Someone challenged me to try to prove, or because this could, if you have a bit flop inside your data, you could potentially lose up to 2 messages. So I have some ideas of how to get around that to say you can only lose the 1 message. I have not had a chance to actually experiment with that yet, but I do have some ideas of keeping data inside of keeping basically a string of the data you've read so far and not read from the visa read, looking for the start bytes and whatnot. Um, Again, I just haven't had a chance to flesh that out. Welcome, Ream Buffer. Yes, Ream Buffers are not exactly my fun. So let's close you. All right. So again, for the intermittent ones, I do the same. First thing I actually do is I use the bytes up port right here to actually say, is there any data? And then that's when I go through the same mess. So basically, we're keeping the same similar structures that we did with the ASCII, but we have to do a lot more due to the bit manipulations or byte manipulations. Any more questions on the binary?
No, but there was a good note real quick about NIO trace and Visa Interactive Control Panel for debugging,
Yep.
as well as in Discord, there's a link posted comparing different hex editors. Just
Yeah,
wanted to bring that up.
I just noticed that one as well. Yeah, the interactive control panel I use quite a bit. Usually, as soon as I get an instrument, I instantly go to the Visa control panel and muck around with it in there. It doesn't work very well, in my opinion, for hexadecimal, but for anything that, especially Skippy, it's great. Um, but I've had no issues using it for anything that does ASCII. It's very much geared towards a command response setup, so be careful with that. So if you're using for an Arduino, I don't recommend using that one. Just make your own terminal real quick. Now I'm just playing. All right. Anything else on these?
Nothing so far. We got about 5 minutes left, and then people can stick around if they want.
Yep. I mean, I got time today until about 1 o'clock. So, what are people's preferred serial port spy programs? I make my own. I just make a simple terminal and I have code just floating around that I've done enough. Real term, I'm also a big fan of Putty. Um, can we use similar approaches with Visa TCP/IP? I actually do. I This code was actually it doesn't work with the bytes up port, so you have that issue. But otherwise, you absolutely can use similar setups. The bytes up port is only serial, but you can use similar setups for your Ethernet or GPIB setups. What do you do for binary call response protocols? I actually use the intermittent setup. Because of the syncing up of the bits and whatnots, I actually have a note in one of my VIs says, due to this, you really should just use the intermittent. And I've gotten my code to where I just use the intermittent setup as my generic setup because it works with the command response. It works with the streaming. So if you want a very generic, look at the intermittent one. So again, I will have this code. Actually, the code is all up on GitHub. I need to do a quick update for this presentation. That's the only thing that's not up to date at the moment. And hopefully I can get this presentation to Quentin and or Michael to have this video in the VIWeek on the LabVIEW wiki as well. But I will hang around here, and I'm also on the Discord if anyone has any additional questions.